Okay, you've probably heard an announcement that this is being recorded. So don't do anything that causes you embarrassment. Although I'm going to switch, I'll switch back and forth to your faces, but I need to pin the video of myself. Well, it's not happening. There we go. Not because I like looking at myself that much, but because when I start writing on the board, I have to be able to see if I'm off the board. Okay. Now, your approach to the course and some things that you can expect from the course. You have the MyOpen Math assignments. My experience in teaching this as a distance course in the fall is that people can find a way to do the assignments without learning anything. I had at least one terrible surprise where a student who appeared to be doing extraordinarily well didn't do as well, and haven't figured out exactly how that happened. And what more than, that happens more than once, especially in distance courses. So I want to warn you against, number one, using your calculator. There's almost no reason to use a calculator in this course. And you'll see what I mean by that. I'll be commenting on that throughout. People reach for their calculator to add 2 and 2. And most of you know what 2 and 2 is. Obviously, everybody does. Now, if you got to multiply 793 by 468, you're going to reach for your calculator. You won't have to do big multiplications much in this course. I've got somebody else waiting. Let me admit that person. We're up to 9 out of 10. Okay. So I'm going to continue talking, but I'll greet our recent arrival when I'm pretty sure they're ready to hear me. So again, the number one thing is you want to read the textbook. We'll have class. You'll want to take notes while we're in class or do something to keep yourself active and keep your attention on what we're doing. Now, I'm going to post the videos, and I'm also going to generally, if I don't somehow forget or get sidetracked, post just a brief video, a 1-minute video showing you the boards that we cover in the class. So you're going to have those available to you. So you have the text, you have the videos, you have the class. And also in the homework, very often there are embedded videos that you can watch to show you specifically how to do this, that, or the other thing. There's also going to be written work. And hello, Jesse, it's good to have you. I've said some things, but right now we're getting to the meat of it, so you haven't missed that much. And we're glad to have you. And I've lost my train of thought, but it'll come back in a minute. What you want to do is you want to solve the problems in MyOpen Math by a method that will reinforce what's going on, that will stick with you and help you build a bigger picture of this course. And that's going to serve you well on the exams. There'll be 2 big exams, a midterm and a final. And most of the points in the course are going to come from the midterm and the final. Now, there's still a significant number of points that come from the MyOpen Math. You can't just blow that off. You lose a couple of letter grades if you do. Even if you do well on the midterm and the final. If you don't do the MyOpen Math, you're looking at best at making a C. And it's going to be difficult if you don't do that homework. Okay, another part of the homework is going to be written assignments. And I think I've alluded to that, but I'm not sure because I'm managing, well, there's a booming, buzzing confusion around my courses right now. There's a bunch of them. So I'm not sure what I've said in one course and what I've not said. I'm working to make sure it's all there. Okay, the thing I'm saying right now is that you're going to send me handwritten work, at least one handwritten assignment a week. And there's going to be one due this week. And I think, wait a minute now. Let me make sure I'm speaking correctly. Take a look at the calendar for this course. Yeah, okay. Your assignments for this week: the introduction to biopen math today, an assignment in exponents tomorrow, an assignment in fractions for Thursday, and then the 5 most basic graphs, something we're going to talk a little bit about today, for Sunday. There's also a video I've already done around the 5 most basic graphs. If you don't pick everything up from what we do today, pick it up from watching that video or parts of that video. Okay. Now, I was talking about how you get me written work. To do that, the most efficient way is going to be if you have a smartphone, which I assume most people do, but I can't assume everybody does. If you have a smartphone, you can easily download an app, a free app, depending what kind of smartphone you have, that allows you to just take pictures of your work and assemble them into a PDF, which is the preferred way to get me your work. I can also accept a series of JPEGs. That's a little more of a pain for you. If you write big enough and write with good contrast, it's not a pain for me. But we'll be working on that. If you don't have the ability to do that, of course, if you have access to a scanner, and the things you send me need to be sent through VHCC email, not through Canvas. Canvas email has its advantages, but it has some real shortcomings. And it's much more difficult for me. I have to do a lot more clicking to get to the stuff in Canvas. It slows me down, and you really don't want to put me in a bad mood when I'm evaluating your homework, although I wouldn't let that influence what I do. But it's kind of a hassle, and it's a distraction, and I won't be able to give you as good a feedback if I'm having to deal with those kinds of hassles. And the main reason that you're getting me the written work, there are 2 reasons. First reason is you need to work on assembling solutions in writing. Okay, that's how you do mathematics. And there's too much just clicking in the MyOpen Math. And the other reason is simply that by writing things out and assembling them, it sticks with you much better and in a different way that reinforces anything else you're learning and avoids that syndrome that I mentioned where people do great on MyOpen Math and can't pass a test. We'll talk more about the way we're testing. You're not going to have multiple choice tests. They're going to be handwritten tests with time limits. And they're going to be structured in such a way that you have to show me what you really understand instead of going to a calculator and getting an answer and saying, here's my answer. I've got to see the steps. So that's kind of an overview of what to expect, but let's go ahead and get into a little bit of math here. Okay. If there's a central concept in the course, and I think there is, it's the toolkit functions. That's what your text calls them, toolkit functions. I call them basic functions, but it's the same thing. And my basic functions are the book's toolkit functions. There's no difference in the functions. So just to start out, and this board's kind of rough. Let's see what I've got on the other side of it. Okay, this is a little better. It'll show up better. Okay. There are several basic or toolkit functions that form the nucleus of this course. Let's position the board so you can see it. Okay. I guess I could move the camera. Okay, basic toolkit functions form the nucleus of this course. The three most basic, the three that I regard as the most basic, and those are the ones we're going to talk about. One is y equals x squared. That's the squaring function. Okay. Y equals 2 to the x. That's your basic exponential function. And y equals 1 over x squared. Which is a basic reciprocal square function. With these functions, you get a pretty good idea of some of the main behaviors of mathematical functions. Now, I was going to do this. When I do the Zoom recording, it's got a banner that goes across this part of the screen. So I'm going to lift this up a little bit. So in case that banner is obliterating it, you'll be able to see what I've written. I try not to write there. When I do, I'll try to lift it up so that if you're looking at the video later, you'll be able to see it. Okay. Now, the shapes of these functions. Well, I'm going to actually construct them without explaining how I'm constructing them, because that's explained in another video that I'm going to ask you to look at. Just marking off a set of axes, and I'm going to plot some points. Okay. I'm going to plot the point. Okay. Okay, these are all going to be units. I want to cut this one in half, and then I want to cut that in half. And I want to cut this interval in half. Again, details of this process are in a video that I'm going to ask you to watch. Okay, now I'm going to plot a point here, point here, point here, point here, and a point here. And each point goes to a couple of the marks on my graph. Okay, this is one of your basic functions. You can do the same thing. I'm not going to say which, because you get that very easily when you construct your own graphs. Now notice when I construct these, I start with the extreme points And then I cut intervals in half. So if this is x equals 2, this is x equals 1. And then if I cut this interval in half, I get x equals a half. And generally, most of these functions will be graphed on a scale from 0 to 4. So I start with 4, cut that in half, and then cut each of those intervals in half, and try to do that as accurately as possible. And again, I want you to hand draw these, and I want you to try to hand draw them at least as well as I have. It's not a challenge to do this as well as I do, because I don't do it all that well. Okay, so another function would be wrong point. And I want to do subdivision on this last interval here. I'm going to subdivide that in half and then divide that interval in half. And that last interval is going to give me this point and this point. Going to have this point. Going to have this point. So there's another function. These are basic functions. And I think I've got room to do the third one. And you want to try to do this as well as you can so that these intervals are all as close as you get them, the same length. Got a point here, a point here, a point here, a point here, and here, and here, and here. Okay, so we can see where these points are. Okay, these are the basic functions. Basic functions consist just of these points, nothing more. I'm going to put little X's on these points so they'll be visible when I draw curves. And now I'm going to draw smooth curves. Okay, so I'm going to draw a nice smooth curve through these points. And I'm going to draw a nice smooth curve here. And I'm not going to connect these 2 points for a number of reasons, but one is because it's not clear how they'd connect. Do we come up to here and then just go straight across? Do we come up a little further and then come back down? Do we come up here, do a couple of loops and come back down? We come down here and back up? You don't know. It turns out that for this function, you can't cross this line. So not knowing what to do, we don't do anything. For the other 2 graphs, it's very clear what to do because the pattern is very clear and it's uninterrupted. This pattern is interrupted by the y-axis for reasons that aren't hard to understand, and we will talk about them. Didn't do a great job with that one, didn't hit that point very well, but you get the idea. Okay, so can you see that? Yeah. Basic functions are in this color. The basic functions consist just of points. The extended basic functions are the blue curves. And that's it. And that's these three functions. The extended basic functions start with the value at -2 and end with the value at x equals 2. In all cases, they don't go beyond the x interval from -2 to 2. So we would say that the domain of the basic functions is the interval from -2 to 2. Now the second assignment in the MyOpenMath, the second actual assignment once you get into chapter 1 is on domain and range. So I'll just mention it right now. So the domain of all the extended basic functions is -2 to 2. The range is a set of possible y values. Okay, and in this case, the y values go from 0 to 4. In this case, they go from this value, which isn't quite 0, up to 4. Well, the value here is 1/4. As you can see, if this is 1, you subdivide that, you get a half. Subdivide that, you get a fourth, and that's the y coordinate here. So the range of this function, the extended basic function, is from 1/4 to 4. And the range of this is also from 1/4 to 4. So we got domain and range. Now, if you didn't totally understand that, those are ideas that you hopefully have seen, but if you don't, you'll get them. The text is very clear on that. The basic functions, domain and range, the domain of this function consists of all the x values. The domain of this basic function then is the set of values -2, -1, 0, 1, and 2. None of the other x values between those are part of it because the basic function consists only of the points. There are only 5 points there. 5. Okay, there are 6 points here, and the domain of the basic function would be -2, -1, -1/2, then 1/2, 1, and 2. And the domain of this one is the same. You have the -2, the -1, the -1/2, the 0, the 1/2, the 1, and the 2. Actually, it's not the same because this one didn't have 0. Okay, 0 is not in the domain of this function for reasons that will become clear. Okay, now why are these functions such a big deal? Well, among other things, there's some asymptotes involved here. Okay, this function has an asymptote at the x-axis, and asymptotes are important. The values keep decreasing. Matter of fact, from here to here, the value becomes half as great. From here to here, it becomes half as great. From here to here, it becomes half as great. From here to here, it becomes half as great. And it continues doing that. If you keep cutting these values in half, pretty soon, the values over here on the y-axis become invisible. They're so close together, you can't distinguish them. And the curve continues to get closer and closer to the x-axis without any limit to how close, but it never goes below the x-axis. It never goes on the other side. Okay. The same thing happens with this function. Okay. And it happens in a slightly different way. It's not half as much. Like from here to here, it's 1/4 as much. From here to here, it's 1/4 as much. Now from here to the next point, it's not 1/4 as much, but that's something we don't worry about for a while. Okay. And it's going to turn out that this function also has an asymptote at the y-axis. So it's going to continue getting closer and closer to the y-axis if you continue to extend it. Now, if you extend these functions to the entire set of, to all the real numbers, with the exclusion of those that don't work, like 0 has to be excluded here. we call that the complete basic function, and we'll talk about that later. We're not going to use that anytime in the immediate future. Okay. Now, why are these important? Why are these any good? Because really, we're after utility. We're after things that we can actually use to understand different aspects of reality. Okay. Now we can go off into abstract realities too. You have a foundation for doing that in this course, but we're not going to go off the abstract deep end. It's something a mathematics major starts to do in their third year. So unless you end up majoring in mathematics or some very mathematically based field where you got to get into abstractions, you don't worry about that. So we're not worried about abstractions. We're worried about something concrete here. And give you a couple examples of concrete applications of these functions. Okay, one of my favorite applications, I'm going to do this kind of quickly. I do it in more detail in the video I'm going to ask you to look at, but if you totally understand what I'm saying here, you can skip that part of the video. Got a bucket here. If I can get it free. Come on. Okay. Okay, here's a bucket. Got some water in it. If I drill a hole in the side of this bucket down near the bottom, water's going to leak out. And as water leaks out, the water level is going to decrease. As the water level decreases, there's less pressure pushing the water out. Common experience. And you can check that. You can take any plastic cup, a soft drink container, something expendable, bore a little hole in it, fill it up with water, and watch how this stream of water comes out fast at the beginning and slows down, and the water level changes more and more slowly. It turns out that if I take this shape, the shape of this graph between here and here, it gives a very good model of how the depth changes in a cylindrical container with a hole inside. So that you can take this shape here, from this point here down to the point here. And this curve, to a high degree of accuracy, can be used to model how that depth changes. Okay. Now the curve stops here because, of course, after the water stops coming out, it doesn't flow back in. Okay, we know that. It's the second law of thermodynamics, if you like that, but you don't need to know the second law of thermodynamics to understand that once the water's out of that container, it's not going to jump back through that hole into the container and fill the container again. You might catch it in something and pour it back into the container, but the model only works here, which means we've restricted this domain. This function has a domain from -2 to 2. We've restricted the domain so it's from -2 to 0. And now we have a function up a curve that we can use to model the flow. Now, the flow doesn't necessarily go from a depth of 4 to a depth of 0 as time goes from -2 to 0. Okay, we take this part of the curve, we draw it here, then we say, okay, let's see. At this point, the second hand on my watch read 15, and I measured the water depth, and it was 20 centimeters. Now that could be 15 seconds, 20 centimeters. That's what this could stand for. And you want to specify that when you do a mathematical model. And then here, the water depth, I say water depth, I'm gonna say water level. The water level is down to 4 when the second hand has reached, let's say 50, okay? So this point would be 1520, this point would be 450. Okay. If I want to put an X and a Y axis on this, well, the X axis or a T axis for time, the horizontal axis is going to have to be below this point because I've got these coordinates backwards. Time is supposed to be 50 and the depth is supposed to be 4. Time goes before the depth as it did up here. Time was 15, the depth was 20. So this is going to be 54, not 450. Okay, so 4 is your Y coordinate, and that's above the horizontal axis. So your horizontal axis is going to have to be positioned so that the 4 makes sense here. Now, if this is 20 and this is 4, then from here to here, you got to go down 16. So from here to here is 16. Where is 4 more? Well, if this is 20 and this is 4, then 0 should be about here. So I'm going to say, okay, my x-axis probably ought to go about there, or my t-axis. Just by looking at these numbers, this now makes sense. If this is 4, then it makes sense that this is 20. If I put the x-axis way down here, then if this is 4, I can't reach that far, but from here to here is not going to be 20. Going to be a lot less than that. So you've got to use a little common sense. Now, I don't expect you to become an expert at doing this just by watching me do it. I'm just going to give you a flavor of how these basic graphs model real world, okay? So we have these 2 points. Then where is 0 going to be on the t-axis? Well, this is 50, and this is 15. If this is 50 and this is 15, where's 0 going to be? Well, it's not going to be here, because if this is 15, then, well, your distance here is 35, wouldn't make sense. Just make sense of it, it's got to go maybe about here. Yeah, not probably more like here. That's where 0 would be, and that's where your vertical axis is going to go. Okay, now we have a curve that represents that depth. If I've got the right shape, if I copied the shape of this curve down correctly, and if I made a careful graph of this and did a nice smooth curve, I would have a pretty good model of the depth of that water. Having a good model of the depth of that water, I could predict what I really want to know is how deep that water is at 30 seconds. Okay, well, 30 seconds would be about here. If I want the depth of the water at 30 seconds, I can come up to this point on the graph, which has a t coordinate. We'll call this t instead of x. Call this y. T coordinate of this point is 30. And what's the y coordinate? Well, if this is 0 and this is 20, I can put a scale here. There's 20. If I cut that in half, I get 10. If I cut that in half, I get 5. It looks to me like this point is about 8. So estimate the coordinates of this point would be 38, meaning when t is 30, y is 8, and that means when your clock is reading 30 seconds, the water level ought to be 8 centimeters in this case, okay? If I want to know when the water level is 10, I can come across here and estimate the coordinates at this point. Okay, so this point, let's use a different color. So this point looks like it's about, if that's 15 and that's 30, maybe that's 26. Okay, so maybe we've got 26, 10. That's an estimate. Well, we can do more than that. But it turns out that there are a great many things that can be modeled based on a curve of this shape. And this is just one of them. And I'm not going to list hundreds of other things. It's a very common model that we use to make sense of things. Okay. Got about 6 minutes left. This curve. Do this a little more quickly. You know, this curve has an asymptote at the horizontal axis, and I've got to include that asymptote. Now, I'm not sure I did a good job with that curve, but there it is. If this has the shape of this, in other words, if this could be labeled so that the points agree with the definition, the y equal 2, it turns out this is the y equals 2 to the x function. Then I can do the following. I can say, okay, let's say I invest $1,000 at my starting time t equals 0. At a constant interest rate, compounded. It doesn't matter how it's compounded. If it's compounded, it'll behave like this. Now, everybody should know what compounded means, but in my experience, I find that nobody does, even though there's a economics type class required for high school graduation. Incomprehensible to me, but we're going to deal with that. We'll address compound interest. So this is an example from, actually, that's physics, what we're looking at. This is an example that shows you how money grows, or how it also works for population dynamics, how the population grows when, say, an invasive species comes in. Okay, so what we're going to say is that, okay, we want our $1,000 to be at t equals 0. So we're going to put the y-axis here. We're going to say that this is $1,000. I didn't draw that arrow very well, but okay, $1,000 is here. Then your money grows. And it grows exponentially. So that this part of the curve models the value of your investment. Now, depending on what kind of interest you get, well, that tells you how you're going to label this axis. Okay. I'm going to talk about doubling time. Here's $1,000. Okay, well, if that's 1,000, then here's 2,000. Okay, now between here and here, your money has doubled. So this is your doubling time. This is how long it takes to double. If I double this, if I drew this curve right, and it looks like I did better than I did on the other video, this thing doubles again in the same time, and it'll double again. So here's 4,000, and down here is 2,000. If I know how long it takes my money to double, then, and if I know the interest rate, I can easily calculate that. And that comes late in the class when we actually analyze that, when we get to exponential functions. But we want to understand that we can model this by this curve. So if I want to know when we get 3,000, I can say, okay, well, 3,000 is going to be here. So I come over to this curve and down here, and I see that 3,000 occurs after about 1 2/3 doubling time, about 1.7 doubling times. If I want to know how much I'm going to have at some other point, I can do similar to what I did here. Again, this also works if you have an invasive species that comes into an ecosystem. Every time that species reproduces, you have more of that species to reproduce. So you're going to get more and more reproduction, more and more population, and it's going to also tend to behave like this. Okay, now there's a little bit of an overview of why we look at these basic functions and a little bit about how we get them, and the video I'm going to ask you to look at for the assignment that will be due Sunday. And incidentally, I put assignments on Sunday, not so you'll spend all day Sunday working. That's to give you time between Thursday and Sunday to get it done. And you can do that Friday, you can do it Thursday, you can do it Saturday, you can do it Sunday. If you want to wait till the last minute, I don't advise waiting till the last minute, but I do it. So if you do, I'm not going to throw any stones at you. Okay, well, that's kind of an introduction to the course. Your first few assignments ought to be pretty straightforward. If they aren't, and if we find that you're having difficulty, we'll address it. Starting next week, we get into chapter 1. You might want to, and some people have already done a couple of sections of chapter 1. Feel free to go as fast as you want to. The more you get ahead, the more slack you have later if you run into something that you're going to stumble over. So again, final words. We get into the text next week. It would be a good idea for you to just kind of scan the first chapter, get some of these ideas into your head. It makes it easier to understand what you're saying and what you're doing when you actually got to dig into them. It primes your brain, kind of like spading your garden, primes the garden for growing things. Okay. Sorry for the glitch with the Zoom today. I'll be more careful in the future. It's the first time I've ever done that, not attaching the link. If you have questions, I'm glad to answer. And you're welcome to submit questions or ask questions here. If you have questions as you are working the assignments, email me. I monitor the email very frequently. I'll usually get back to you pretty quickly, at least within a few hours. Sometimes it could be a day's delay, depending on what might be going on. But usually I try to get that done very promptly. Okay, I'm going to stop the recording.